Good morning and good day to all of audience and viewer from Masa University Facebook page and YouTube channel. Welcome to the webinar conducted by Faculty of Engineering, Built Environment and Information Technology of Masa University. Today we will be hearing a presentation from Dr. Nadia Jamaluddin. She is a PhD graduate from University Technology Malaysia, majoring geotechnics. Her specialty is soil stabilization. Since her degree years up to now, her research mostly covers soft clay stabilization such as marine clay. Currently, she is a lecturer at Mahsa University that teach geotechnical engineering as well as geoenvironmental engineering. She has article publication in ISI and Scopus Index for both corresponding and co-author. Without further ado, I would like to welcome Dr. Nadia Jamaluddin, who will be speaking to us with topic Microstructure Analysis of Soft Soil Stabilized by Waste Material. Alright, Dr. Nadia, the floor is yours.
All right. Okay. Thank you, Dr. Hanisa. Okay. Good morning. Assalamualaikum all. I believe those who are watching are mostly from Masa University. Hi. All right. So rather than presenting, I rather want to do like a sharing session because I think it's more laid back, more relaxed rather than having a presentation, right? So today I will be sharing about the microstructure analysis of soft soil stabilized by waste material, but actually I will not be talking into research as much because I think it's gonna be quite boring if I'm talking directly to into research because this has been presented so many times. So rather than that, I want to share what I know and how to do microstructure analysis, especially those taking civil engineering majoring in geotechnics. All right. So I will go through. Okay. So for today, I will be sharing from introductions, a bit about FESEM, EDX, XRD, and lastly, we'll talk about some conclusions. Okay. All right. So, moment. So a bit about introduction. So I'm gonna go through one by one, okay, from FESEM through EDX and XRD. But I'm gonna just on the surface and share what I have about my research just a bit, okay. All right, because I would say maybe in the mechanical field or maybe electrical field, they do microstructure analysis in depth. But in civil, especially in soil stabilization, we don't do that as much. We do a bit of microstructure analysis, but when I enter to talks and ask them questions about if there is a certain guideline on how to analyze these data, they will say that there is really no certain standard whatsoever. So I'm going to provide you with the tips. So what is microstructure analysis? It's usually used widely in industry to evaluate products and materials. So those studying products and materials, they would opt to do microstructural analysis for every single material because when we want to research, we need to know and learn every single of our material, right? It's like when we want to get to know someone, we have to know every single thing about them, right? So this is what microstructural analysis do. Sorry, it's a bit mouthful. Microstructural analysis is introducing us what is this material, what is the other material, all right? Okay, so other than knowing the material, we can also take note of the performance, how the material responds to the environment, what are the failure mechanisms, and are some of the areas in which the microstructure analysis can utilize. All right, and then it ranges from simple determination of certain parameters such as grain size, coating thickness, porosity, pore structure, and full characterization of multi-component systems or evaluation of degradation of failure mechanisms. So, in terms of civil engineering, especially in my research mostly done on geotechnics, which is the study of soil and rocks, we cannot look at the material as it is only. We need to look at it in the microstructural view. So doing microstructure analysis, especially in soil stabilization or any material stabilization, I think is quite vital. All right. Okay, so I'm gonna go through this three only because this is what I'm known of, is what I did. So it's on. We're gonna go through field emission scanning microscope. Sorry, FESEM, energy dispersive X-ray EDX, and X-ray diffraction, which is the XRD analysis. I know there's a lot of microstructure analysis tests, but I'm gonna go through this three only. All right. Okay. Okay, we're going to the FESEM. All right, it's actually a camera. If you want to put it into layman terms, it's actually a camera or a microscopic. Uh, what is it? Microscopic. What is it? Device to take a picture of the materials microscopically. So we can get magnification from 10,000 to 300,000, depending on what you're looking at. So I'm just talking about the testing and the equipment itself, okay, one by one. So it is actually a microscope which uses negatively charged particles, electron, in order to scan the objects. And then from this equipment of FESEM, we will also get EDX, the one that I've shown here before here, right? Energy dispersive X-ray. We can get two data from the same machine, which is actually an elemental analysis, which can be done by either point, line, or mapping. All right. So to put it in layman terms, FESEM is actually taking a picture of the materials itself microscopically, so we can see what is happening under there. All right, okay, so sorry, it's moving. Okay, the EDX, which we can get from the same machine itself, is actually an elemental analysis, which meaning you can get how much is the silicon, how much is the calcium, how much is the oxygen, that kind of stuff. Okay, all right. It's using the same equipment as the FESEM. All right, so usually when you do this testing, some technician will prepare your sample for you because it's actually a very delicate machine. You cannot just simply prepare the sample by your own, but as a master or PhD student, you are required to know and you are required to prepare your samples by yourself. So you only take like a bit of material. If it's soil, it's passing 63 micron because you want it to be very, very fine, and then put it on a specimen holder. And after that, it will be coated with platinum actually, using an automatic platinum sputter coat, and then paste. You can already place it in the machine, and then you can look at it microscopically. That's the process of preparing the sample itself. Okay. All right. So this goes for both FESEM and EDX. Okay. So another one that I think is quite familiar kind of test is actually the X-ray diffraction. I think most of you are very familiar of this, and maybe they have done this testing as well. Whether you are civil, mechanical, electrical, I think you're very familiar with this test. So it's actually a test to determine the crystallinity of a compound. All right. If before we were taking a picture for FESEM, and the second one for EDX, we're taking note of the elementals such as silica, alumina. For XRD, we are taking note of the compound. All right. So usually the sample itself will be in a powder form, 63 micron passing, and you will get data from 2 theta, which is 3 to 90 degrees of angle. All right. And when you already get the data itself, you have to match it. No worry, I will show you some kind of samples of data that I already have. Okay. Like I said, this is more of a sharing session, what I did, rather than showing what my research is. Okay. So in terms of preparing the sample, usually if you're degree students, the technician will prepare it for you, but for masters and above, they would have to prepare the sample by themselves. So you will put the sample on a sample holder. Mostly they will use like about 63 micron of material size, and then you put into the machine, and you have to directly analyze it by matching the data of the library of the mineralogy available. All right, so it's quite interesting because now you know the compound that is available, the new compound, new material that might be available. It's okay, I'll show you some of the results that I have after this. Okay, all right, so we're gonna go through one by one. Okay, first we're gonna go through with the FESEM. Okay, like I said, FESEM or field emission scanning microscope is actually taking a picture of the material itself. All right, so this is some of the picture of marine clay. Marine clay is actually a type of clay that can be get from the sea itself. It's a type of clay that is that has low strength. You cannot build structures on it. Just a bit overview of what is marine clay. So when doing FESEM on it, you can see that the picture from the picture you can see that the particles are arranged with flakes and then arranged in a book-like structure. Previously, when I went to a talk about this FESEM, about how to determine or how to read from the FESEM picture, I've asked from the specialists, they say that there is no really one way to determine or read from it. All right. It's up to the eyes of the beholder itself, and maybe you can research it from previous research. Okay. So from this picture, from what I can see and from what I've read before, you can see that the structure it's very flaky. They arrange in a book-like structure, like that, and then it has slaty particles here. So some notes about how to do some FESEM is some tips, and these tips I always share with some of the those who are doing FESEM as well. When you do FESEM, you must know what you want to do. You must have to do some research. You must have to do your homework. Okay, do your homework. Learn. Okay, if for example, if doing marine clay, how would the picture look like? How would it be? What am I searching for? It's important when you're doing something. You have to do your homework first. So, firstly, you need to know. You need to learn first. You need to research a bit. Okay, what am I looking for? Because when you're doing the testing, when you're about to take the pictures of the sample itself, it will be very confusing. So before going into the testing, you must learn a bit, do your homework. Okay, what am I searching? What is it that I need to know? What am I about to do? So when you want to compare this picture, you have to first and foremost, after doing your homework, second, when you're about to do the testing, you will have to compare the picture with a lot of pictures. So you must take all the pictures at the same magnification. Okay, like I mentioned before, the magnification ranges from 10,000 to 300,000, right? So you must set what kind of magnification. For example, if you're taking 10,000, you must take a picture for all in 10,000. So you would compare it at the same magnification, because people will ask, right? If it's different magnification, it's not the same thing that we are comparing. So after doing your homework, compare the picture with the same magnification, and then in terms for my mostly for my studies, we would compare for soil stabilization, right? So when comparing for soil stabilization, we will majorly look at the pores, the pores available in the picture. So because why we're comparing the pores is mostly because soil that have a lot of pores is considered low in strength. All right. So when we want to compare, we will compare with the control specimen, and we will compare with the stabilized specimen. So, like I mentioned, the same magnification, and from the control or from the initial like marine clay, you compare with the stabilized marine clay, for example. All right. You have for me, I am looking for the pores inside the soil. That is what I need to look for. If it's about marine clay, it's about soil stabilization. For different material, you might want to be searching for different things. Might you want to be searching for rust? You might want to be searching for cementatious product. like concrete itself. So for different material, you will opt for different things. So you need to know what you are doing in advance. Okay, so in my case, I will search for pores, pores, pores. Okay, then I will compare it with the stabilized sample to see if there is any difference between it both. Right, but like I said, there is no accurate way of determining this. It's more to the eyes of the beholder, and you also can use. Sorry, I'm changing the next slide. Okay, this is also some of the pictures of materials that I've used is fly ash. From here, you can see that the fly ash sample is in spherical form. It's very smooth as opposed to if I'm comparing it with bottom ash. It's also spherical, same types of material, but it's very rough around the edges. That's how you describe it in terms of material itself. Okay, this is some of what kind of materials that I've been using before. Okay, so this is some of the pictures of what a stabilized marine clay look like. So you can see that before we see that there's pores. It's like, let me show you the previous one. All right, sorry. Before it's flaky, it has pores, it's arranged, it has slits. All right. So now when it's stabilized, the addition of cementatious product, there's less pores in there. There's addition of trinket as well. Like I said, this is up to the eyes of the beholder itself. But then there is one way you can determine, especially in terms of the pores of the pictures of how to know whether the pore percentage has decreased. There is a way of determining that. That is by using a software called ImageJ. Okay. If you're looking at the pore components here, you want to know, you cannot just look at by the eye, you cannot just calculate it like that. There's a software you can use which is called ImageJ. I have the software if anyone is interested, but it's actually free to download as well. So you can see here, this is the actual image of a marine clay. And this is when you put it under the image J, and the black parts are the pores. So from here, you can determine, and you can see, and you can get a percentage of it as well, whether the pore percentage already decreasing or not. Okay, I have that of it. All right, so this is what I did before. I've compared a data of marine clay stabilized with fly ash and bottom ash, a combination of both with a bit of cement. So I compare it with days, okay, from 0 days, 7 days, and 28 days. All right. So by our eyes itself, we can see that the pore percentage has decreased, the black ones, right? But we also have a data here that can see from the percentage area of the black region is decreasing days with increasing days, right? From 19 to 0.277 to 0.255 and 0.226. So in terms of pore percentage, or the ones that are in black here, there is actually a way to determine, right, by using ImageJ. I think some of you are very familiar with this, but this is how you get an accurate percentage of it. So this is one way to get to analyze the FESEM or field emission scanning electron microscopy data. All right. So long way to go. We're just finished with FESEM, I think. Okay. All right. Some of the pictures that I have from previous. It's okay. We can go through this. Okay. That is only one part of microstructure analysis. I'm going to go through the energy dispersive X-ray or EDX, which we can get the data from the same machine. Good. One machine, two data. Good. All right. So this is actually a very easy and straightforward kind of testing analysis, because when you put the sample in the machine, you will directly get an information of what is exactly in there directly. It's just you need to know what you are looking for. When doing anything, whether learning or doing research or maybe being a lecturer, you might have a lot of additional knowledge, but if you don't know what to do, it will be some kind, they say, like rubbish. So equip yourself with the knowledge that is appropriate. If you don't know, go and learn so you know how to analyze whatever it is in comes to you. All right. Okay. So sorry, a bit the talking. So we're on to the energy dispersive X-ray or EDX. So actually, EDX, you will get, like I mentioned, is actually you can get an elemental analysis of the sample itself. So if you're trying to find the calcium percentage, or maybe the iron percentage, this is a good thing, from the data of the FESEM or from the testing of FESEM, then you will get the data for the EDX. All right. EDX easier to say, right? So this is some of how to say some of a bit of my analysis results from my previous research. So you can see, you can find the percentage of silica, alumina, calcium, ferrum, magnesium, and this is some of the rough data here. All right. Okay, when doing EDX or energy dispersive X-ray, first and foremost, like what you do for everything, you have to do your homework. Okay, you have to learn, you have to read a lot of papers or posts on what am I doing, what am I searching. Okay, so you need to know that first. So when you know what you're searching, it's easy for you. If you just in blindly, you might not know what to do, you might do something wrong, because these kinds of tests is quite costly, and you have limited amount of time to analysis it. So you have to come there with the knowledge in mind, so you would know what you're going to find. Especially in some universities, you pay about like 300 per sample. That is in universities. Outside is much more expensive. So with the payment that you made and the time that you're doing, limited time, you have to get a proper analysis of a certain data. All right, so like I said, first and foremost, you have to do your homework, learn what you are searching, know what you are searching for. Refer to previous research, what kind of elemental that is required to be searched. Okay, for example, for my kind of research before, I was doing on marine clay and stabilized with fly ash, bottom ash, and a bit of cement. So for my research previously, one of the thing that important for me to look is the silica and alumina. Why? Because this is actually the elements of marine clay, that build up of the marine clay. And these elements are going to increase or decrease depending on the cementitious product or the stabilization products, which are like calcium, ferrum, magnesium, sulfur. So these are some kinds of the elements that I need to take note of. All right. So, like you can see here, this is the silica, alumina, and calcium. All right, that's what is actually most important when what you can look at. With increased percentage, they should be for especially stabilized soil. The calcium should also be increasing as well. This is one of the ways of looking at the elements itself. Like I said, you need to know what you are looking for. If you're looking for rust, you might need to look at ferrum. That's some of the things that you need to look for. And then, like in my case, I'm looking at the increment of cementitious product, like calcium, and the decrement of soil, such as silica, alumina. Why would it decrease? Because it will react with the cementitious compound and become a cementitious product and will become another compound, which we can check and analyze in the next test that I will be talking about. All right. So this is actually a data from my master's, and this is a data from my PhD. I'll check it. This is a bit. I'm checking more on the calcium for 0 and 7 and 28 days. Yeah, I know the calcium is quite low because I'm using waste materials mostly. For my master's, I use demolished concrete. For my PhD, I did for fly ash and bottom ash and only 2% of cement. So the calcium is not as much. It's permissible so long as you know what you are doing. It's fine. Okay, don't be stressed. All right. Okay, so this is actually X-ray spectroscopy or EDX. Actually, a simple data to analyze. Easy. Everything is there. You just need to extract what you want. They can give you a lot of things. You just need to know what you want. If not, you will be in the blind, in the dark. So it's very tough for you. All right. So done because this is quite short for this one. So now on to the third one that I've been talking about, which is actually X-ray diffraction or XRD analysis. Okay, this one is quite a tough one, in my experience, because you need to find the compounds. You're not finding elements. You're not taking pictures or selfieing with the soil or materials. You are actually looking or searching for compounds. All right, which is quite tough if you don't know what you're doing. Okay, all right. So similar when you want to do XRD or XRD analysis, first and foremost, if anything, same as the previous test, you have to do your homework. You have to know what you are searching for because this is also going to take a lot of time when you're doing this kind of test. You're going to be in front of the computer for quite a long time looking at it, finding the compound you want, searching what is important because you're not going to need every single information. You only need the critical information. You don't want, if they have like 100 compound there, you don't want them all. You'll be very confused. Not everything is important, right? So first and foremost, you must refer your from previous study, read from books, read from papers mostly, to know what kind of compounds you are searching for. All right. So after the machine already gets some information on what the compound, there will be hundreds and thousands of components there. So you need to know what you are searching for and do the matching. What they say, they call it matching on the graph itself. Okay. And then when you compare the data, you need to acknowledge the peaks. Okay, I'm gonna show this. Okay, this is actually previous data initially. So this is actually marine clay stabilized with demolished concrete. So matching is actually determining which peaks, which compounds. That is important. Okay, so inevitably for my kind of research, I'm gonna find the peaks for marine clay, which is silica, or they call it quartz, silica oxide, and I'm gonna find the calcium here, and I'm gonna find gates as well because that is what is available on demolished concrete. This is one of it. So then after you already match the compound with the peaks itself, all right, and then you have to compare with the days. Okay, for example, I'm comparing with 07, the control 07, 28, and 60 days in this research itself. So when you want to compare it, you have to look at the peaks, whether it's decreasing or increasing. In my case here, the calcium is actually decreasing. Calcium aluminum oxide, the cash or CASH, that is actually the most important component in stabilization, is the cementation product, is actually decreasing. And it's not wrong. Nothing is wrong in research. It's so long as you know how to analyze it or how to explain it, everything's right. It's knowledge. Nothing is wrong. How could knowledge be wrong, right? So after this is one of it. Okay, there's another one during PhD. You can look at the peaks. Like I said, most importantly, you look at the peaks that you are most interested in. For me, my is the soil peaks, silica oxide, which is quartz. K is the columnar, is also the soil. Look whether it's decreasing, increasing. If it's a good stabilization process, like in terms of my previous research, if it's a good if good stabilization is happening, the soil or the peaks for the soil would decrease, and the peaks for cash or the cementatious product will increase. That is what you should look at. The critical part in doing this analysis is mostly on finding the compounds that you need. In my case, I have to find a new cementation compound that would appear. So I have to find that. So that is going to be quite tricky to find. Different, because sometimes when you mix different materials, different new materials, they will form something new. So you have to keep an open mind. You have to search one by one and be very patient. That's mostly so for me. Out of the three tests, this one is quite critical for me, especially in finding the new cementatious product. Right? Okay. I don't know about the rest of you, but for me, this is all right. All right. So just to conclude, for me, microstructure analysis, or the three types of tests that I've just mentioned just now, is quite vital in terms of the material itself. I know in civil or maybe mechanical, electrical, they are already in depth of the microstructure analysis, but in civil, we are still, especially in soil itself, we are still not into it as much as opposed to the others. But for me, in terms of stabilization, if we're doing soil stabilization or anything regarding the material itself, it's important to know and learn wholeheartedly what is the material, what is inside the material, what are the compounds, what the elemental procedures. So this is actually quite a very important test. It's just that it's expensive. It's because in some universities you have to queue to get this kind of test, or you have to pay outside. So it's quite expensive because you're not going to do one sample. You're going to do minimum maybe 20 or more just to get the information or the required data that you want. And it's going to take quite a long time to get the right one. So for me, it's vital to do this kind of, especially these three kind of testing, in order to determine whether there is soil stabilization, whether there is improvement of the soil, whether there is any problem with the material itself. All right. So thank you all. Just as a conclusion, I hope you gained something from this sharing session. I just shared with you what I know and what can you do and how can you prepare yourself for doing these kind of tests, because during my time I don't really know what to do and there's not much people to guide me. So rather than keeping what I know, it's good to share, right? Mostly sharing your knowledge. Okay. All right, Dr. Anissa, I'm done.
Okay, we have come to the end part of the presentation. Thank you very much, Dr. Nadia Jamaluddin, for addressing this interesting topic for this sharing session. Hopefully, the presentation was beneficial for everyone. On behalf of Masa University, we would like to thank you for joining us today. Thank you for your time and cooperation. Goodbye.